Okay, so in this video, we will be looking at how to give a detailed solution to this interesting equation here. And one way we can achieve that is to apply the Lambert W function. And for us to be able to apply this Lambert W function to this equation and make us get our solution in the end, we must be able to also transform this equation to be in this form. Because from the Lambert W function, notice that we have e and a power x and another x here which are the same. So, and we have it here also, e and a. Also here we have e, b, power b, and b here. So for us to be able to use this equation has to be in this form. I repeat, for you to be able to apply this Lambert W function to this equation has to be already in this form for you to be able to successfully use the Lambert W function or the product log. So the main aim now will be to first try our best to rewrite this equation to look like this. And we have to be careful. It's not just rewriting the left hand side to look like this and the right hand side to have this pattern. You should be able to also make sure that while the equation is looking like this, the variable x is on one side of the equation, either on the left hand side or on the right hand side, while it is still looking like this. So you will require a rigorous algebraic manipulation to be able to achieve this. If you can transform this equation to this, then you are good to go. Remember that. Transform this equation to be in this pattern, and while you are transforming it to be in this pattern, make sure that the variable x is on one side of the equation already. So you have to be careful. So your laws of logarithm and indices will play a major role in your manipulation. So once it looks like this, we can then apply the Lambert W function. And of course, you can see once it looks like this, is easy. Once you apply the Lambert W function to a term that looks like this, it neutralizes the term to only the power. Of course, the power x here and the number x are the same. So if you apply the W, it gives you only x, only one of them. So if I can have it in this form and I apply the W, I'll have just a on the left hand side. Apply the W here again, I'll have just b on the right hand side. So now our journey begins. Remember to transform. We are transforming this equation to be in this form. That is the ultimate aim, for us to be able to apply the Lambert W function. Okay, so let's head on. So rewriting the equation, I have x raised to the power x equals 2 raised to the power 2x, then plus 8. Plus 8, the 8 is in the power form. Let me rewrite this. X raised to the power x equals 2 raised to the power 2x plus 8. Yeah, it should be as a power also, included with the 2x. So I can reverse this using the law, one of the laws of indices. And of course, we know it is this law of indices. So let me put it here. So using this law, we can rewrite this. So this now becomes x raised to the power x equals, this one now becomes 2 raised to the power 2x times 2 raised to the power 8. So going further, of course, we know that 2 raised to the power 8 is 256. That's 2 times 2 times 2 times 2 in 8 places. We're going to get 256. So we now have x raised to the power x equals 2 raised to the power 2x times 2 raised to the power 8 is 256. And then going further, I can manipulate this term here, this 2 raised to the power 2x. So I have x raised to the power x equals, this one can now become 2 raised to the power 2 all raised to the power x, then times the same 256. And don't forget, it is the same because they are commutative. So 2 times x still gives me my 2x here, still following laws of indices. So I now have x raised to the power x equals 2 raised to the power 2 is 4, then raised to the power x, then times 256. Then here I can divide both sides of the equation by this 4 raised to the power x. So divide here by 4 raised to the power x, and also divide here by 4 raised to the power x. So this cancels out this. I'm left with 256 on the right hand side of the equation. And here they have a common power, so I can pull out one power. I can now have x over 4 all raised to the power x, since they have a common power, then equal to, and I have 256. So now that I have the equation in this form, I can now apply the natural log on both sides of the equation. So I can now have it as ln of this value, applying log to both sides now, ln of this x over 4 raised by x equals to, do the same thing here, you have ln of 256. Then of course from the laws of logarithm, the power here can move over here and be in product with the term here. So this x comes here, and now you now have x ln, of course I still have my 4, x over 4 rather, x over 4 equals to ln 256. Then here, remember our main aim. The main aim here is to make sure that the equation looks like this. So what I'm going to do now is I will try and look for a way that I can introduce e to the left hand side and also do it to the right hand side. But let me first start with the left hand side. See how I can look for a way to manipulate this e and let the e be in the left hand side of this equation. So I can do that by rewriting this x rather in terms of e. So let me follow this trick here. Remember that we can say that e raised to power ln of a is also equal to a. So I will say e raised to power ln of x will also give x. So I can have it that e raised to power ln of x is equal to x. So I can rewrite this x in this form. After all, this and this are now the same thing. So instead of leaving this x here, I'll put e raised to power ln of x here. They are the same. So I'll do that now. We're getting closer. So instead of writing x, I'm writing e raised to power ln of x here. So that's e raised to power ln of x times this ln of x over 4. Then equal to, I still have my normal term here, ln of 256. So let me just interchange them. After a times b is same thing as b times a. Let me just write the ln of x over 4 times, and I have my e raised to power ln of x is equal to ln of 256. We are getting closer. So now, still coming to this left hand side of this equation. So the left hand side of the equation, we can still do some other manipulations to make us achieve our goal. So here, I can rewrite this or reverse this using one of the laws of logarithm, and that's under division. So remember, we have, if you have ln of a over b, it's same thing as ln a minus ln of b. So I'll do that here. So rewriting this to be in this form, I'll have it as ln of 4 of x rather, ln of x minus ln of 4, then times, of course I still have my e raised to power ln of x equals to ln of 256. So again, we are almost there. As you can see, we're almost there. Remember, the goal is to have our e and make sure that the power for e and the term in product with the whole term here must be the same. This and this must be the same, but it is still not yet the same. We're almost there. ln of x we have here. So how can I make this term and this term be the same as it is in this pattern we talked about earlier? So I can do something here. I can divide here by e raised to power ln of 4. So divide the left hand side by e raised to power ln of 4, and also do the same thing here and see if it will later become in this pattern as we talked about. So I will divide here by e raised to power ln of 4, and also do the same thing here, e raised to power ln of 4. So this divided by this, we can follow one of the laws of logarithm. See now, e raised to power a divided by e raised to power b gives you e raised to power a minus b. So I'm doing the same thing to this guy here. So this one now becomes, after dividing these ones, I'll get e raised to power ln of x minus ln of 4, since they have the same base and you can subtract the power, just like what we did here. The same base, pick one base and subtract the power, one of the laws of logarithm. So Still fix your other term here, times ln of x minus ln of 4, then equal to, I have ln of 256 over e raised by ln of 4. Don't forget, still simplifies to 4, like what I showed you earlier on, which is here. Remember that e raised by ln of a simplifies to a. So e raised by ln of 4 will give you 4 down here. Let me put the 4 down there. So I have 4. So now I think I have achieved it on the left hand side. So finally, the left hand side is looking like this. See what e? The term here is the same thing as the term here, just like I have my e, and I have a, and I have a. So this left hand side is looking like this now. We now have to do the same thing to the right hand side. This is now what we need to work on. So this right hand side has to be like this also to make my work easy. So we are done with the left hand side. Let us focus on the right hand side and let's make sure that it looks exactly like this too. So let's focus on this now. So this is okay. Left hand side is perfect now. We now have ln of x minus ln of 4 times e raised to power ln of x minus ln of 4 equals ln of 256 can be ln of 4 raised to power 4. Yes, because 256 can be written as 4 raised to power 4 over this 4 down here waiting for you. So we now have, continuing from there, we would have, we have ln of x minus ln of 4 times e raised to power ln of x minus ln of 4 will have, so equals to, for laws of logarithm, we will know that the 4 can come over to this side here. The power 4 here can come over here and become a product with the ln 4, ln of 4. So we now have 4 ln of 4 over the 4 here down. We can now say this cancels this. We are left with ln of 4. So we are getting there. So we now have ln of x minus ln of 4 times e raised to power ln of x minus ln of 4 equals to, we just have only ln of 4 left. We can rewrite ln of 4 as ln of 2 raised to power 2, because our aim, don't forget what I said, we are trying our best to make sure that the right hand side of this equation, ln of 4, is in this format, becomes in this form. So let's continue. The left hand side is okay. The power here and the term here, they are the same thing. So we now have ln of x minus ln of 4 times e raised to power ln of x minus ln of 4 equals to, this one can now be ln of 2 raised to power 2. And of course, we know the 2 can come over to this side. So we now have ln of x minus ln of 4 times e raised to power ln of x minus ln of 4 equals, the 2 can come here and become 2 ln of 2. So now we are almost there. So this is getting closer to what we want it to be. Now again, what we did before, we need to look for a way to also introduce this e to the right hand side, just like how we introduced e to the left at one of the stages. So how do I introduce e to the right hand side to make it be in this format? I will rewrite this 2. I can write 2 in terms of e. So, and of course, we are going to do the same thing we did before. So if e raised to power ln of a equals a, I can say that e raised to power ln of 2 is equal to 2. That means instead of writing 2 or leaving this 2 here, I'll replace the 2 with e raised by ln of 2 since they are the same. Then finally, we will now have the e written on the right hand side. So let's go there. So rewriting this 2 in terms of e, I'll have it in this form. Let me first write the left hand side. I know we are done with that. So we now have ln of x minus ln of 4 times e raised to power ln of x minus ln of 4 is equal to, these 2 can now be written as e raised to power ln of 2 since they are the same, times this ln of 2 waiting for you there. Let me just swap, let me put the ln of 2 on the other side here and put the e raised by ln of 2 here. They are still the same, they are commutative. So it's still the same, they'll still be in the same, they still give the same result. So we have ln of x minus ln of 4 times e raised to the power ln of x minus ln of 4 equals to ln of 2 times e raised to the power ln of 2. Finally, the right hand side is now in the form that we want it to be. So finally, the left hand side has e and has the same term. This term and this term are the same, just like how we have this term and this term the same. And then the right hand side has the e, and then the power and the term here are the same. So finally, we can now apply the Lambert W function on both sides of the equation because they are now in the form that can accept the function. So remember, once you apply the Lambert W function on the term, see x and x the same, the x will now be your result. So if I apply it here, I have ln of x minus ln of 4 both here. That means one of them becomes my result, and the same thing here too. If I apply it on the right hand side, ln of 2 will become the answer I get. So let me apply the w on both sides. So applying the w on both sides, watch and learn. So I now have w, open bracket, I'm applying it to this side, ln of x minus ln of 4 close bracket times e raised to the power ln of x minus ln of 4 equals to w of this side also. I'm applying it to both sides. ln of 2 times e raised to the power ln of 2 close the bracket. So applying this w here means I'll just pull one of these terms. They are the same. This one and this one are the same. I'll just bring any one I want out. So let me bring this one out. ln of x minus ln of 4 equals the same thing here. The ln of 2 here and the one here are the same thing. I'll just pull only one out. So if you apply the Lambert W function or the w, it should neutralize this to only the power or the coefficient here. So I'm picking one of the ln of 2 here. So the equation is now looking so simple. So now I can rewrite my 4 to be 2 raised to the power 2. So I now have ln of x minus ln of 2 raised to the power 2 equals to ln of 2. The 2 can come over to this side, and I have ln of x minus 2 times ln of 2 equals to ln of 2. And then collecting, I can pull this one over to the left, and I have ln of x minus 2 ln of 2. This ln of 2 becomes minus ln of 2. I have equals to 0 on the right hand side. So I can do an arithmetic here because they are the same. So they have the same term. So I have ln of x minus 2 ln of 2 minus ln of 2 gives me minus 3 ln of 2, then equal to 0. So I can pull this 3 back to this side, and I have ln of x minus the 3 now comes over and becomes ln of 2 raised to the power 3 equals 0. And I have ln of x minus ln of 8 equals 0. Then following subtraction law for laws of indices, pick one ln and divide the arguments. That's x over 8 equals 0. Don't forget that ln is the same thing as log to the base e of x over 8 equals 0. Then to solve this, e raised to the power 0 must give you everything here. So I will then have it in this form. So we are almost there. So we have e raised to the power 0 equals x over 8. So x over 8 equals e raised to the power 0. And of course, any value raised to the power 0 is 1. So I have x over 8 equals 1. And then of course, if you cross multiply, x times 1 x equals 8 times 1 8. So x equals 8. So that's it. See you in my next video.